Okay, this time let's try a different example. This time we're asked to find the solution region to the system of inequalities x plus 2y is less than or equal to 4 and x minus y is less than or equal to 3. For both of these lines, we're going to use solid lines to represent the greater than or less than or equal to. So we're going to graph x plus 2y equals 4 with a solid line. I'll put that in black, and then we'll use in red x minus y is equal to 3. So we can see the two things together. All right, so how does this work out? Well, let's graph in black right here. X plus 2y is equal to 4. We know that if we use our y-intercepts right here and we let x equal 0, that's going to give us y equals 2. So 0, 2 is 1 point along this graph. If we let y equals 0 and find the value of x that goes with it, we're going to get x equals 4. So the point 4, 0 is a second point on this graph. And if I were to plot the points right here by following the bouncing balls, let's just following the slope back so I can get a nice long line that follows that pattern there. There it is. All right, this is our line. Of course, we want to use a test point to see which side would be shaded in. So we're going to try 0, 0 as our test point again. The test point in this case, 0, 0, gives us 0 plus 2 times 0 should be less than or equal to 4. Yeah, that's true. So everything on this side of this line is going to be shaded in. So I'll just put a couple of arrows there to indicate that before I do any actual shading. Let's try it in red here. X minus y equals 3. So if we let x equals 0, we get y equals negative 3. So our point 0, negative 3 would be the y-intercept. If we let y equals 0, we're going to find x equals positive 3 as the x-intercept. And if we plot our line through those 2 points here, and let's use red to do that. Let's see how it comes out. Then our line should go as follows here. Straight through these 2 points, solid line. And of course, we want to test to see if our line, use our test point again right here to see if that works at 0, 0. Does it? Well, 0 minus 0 would be less than 3. So yes, that's true. Everything above that. So what are we going to shade in? You've got it. Okay, and we can see our region where these two seem to intersect with one another. And if we were to actually find the point where the intersection occurs, let's see if we can get a nice pin going here. We're looking for this coordinate point right here. I'll do this in black since it's a little bit easier to see. We're looking for this coordinate point. So we will be looking for the solution to the system x plus 2y equals 4. And x minus y equals 3. So I'm going to take my second equation by the addition method, and I'm going to multiply it by negative 1 on both sides. So that's going to give me x plus 2y equals 4, added to negative x plus y equals negative 3. And doing some addition right here gives me 3y equals 1, which is to say y equals 1/3. And for our x value, well, let's just choose this second equation right here. If x minus y is equal to 3, then x minus 1/3 would equal to 3. So we would have to add 1/3 to both sides. If we add 3 to 1/3, what do we get? I'll take a minute to figure that out here. That's right, you should get 10/3. And so our coordinate point right here, this point of intersection, is going to be found at the point 10/3, which would be about the same as 3 and 1/3, and 1/3 for y. One more example. All right, this time we're going to make it a little bit more difficult. We want to find the solution to the region y is greater than 2x minus 3 and y is greater than negative 3x. Well, in this case, now we're going to have to do, again, a little different thing. So let's use a green right here for our first equation. Y is equal to 2x minus 3. How would it look? Well, in this case, we're just going to use the slope-intercept method. Our y-intercept is at the point 0, negative 3. Our slope is 2, so every time we go to the right, up 2, we have to go to the right 1. Up 2, right 1, up 2, right 1, and so on down the line right here. So if I draw this line, let's choose a good color here. There we go. We're going to use a solid line for this one, and it will go kind of like this for each of our points, and it would be a solid line. And we could use a test point right here. We could use the point 0, 0 in this case to see if that's true. So let's set up our test point right here. Does our test point work? Well, 0 would have to be greater than 2 times 0 minus 3, and so 0 is greater than negative 3, so yeah, that's true. Everything on this side of the line works. Now let's try the other line. This time let's put it in a nice different shade right here. How about y equals negative 3? What would it look like? Y equals negative 3x. Well, if y equals negative 3x, that means there is a intercept at the point 0, 0, and the slope is negative 3. So every time I go down 3, I have to go to the right 1. Down 3 to the right 1. And so on down my line right here. So if I want to graph this line, this time in this lovely purple shade here, let's see what we get. Let's start up here, work our way down. And of course, we're not done yet because we do want this to be a dashed line. So let's make sure it's dashed. There we go. Okay, right? We're using the greater than symbol right here. We can't use 0, 0 as a test point, so what do? Well, if we can't use 0, 0 as a test point, next best thing, use 1, 1. Let's see, does 1, 1 fall on the line right here? Well, as a test point, 1, 1 would mean that 1 is greater than negative 3 times 1. Yeah, that's true. Sure, everything over here is going to be shaded in. So what is our shaded region? That's right, it's everything where these two guys overlap, and if we're interested in finding those points of intersection, we're going to have to figure out what that is. This one point of intersection right here. This is not a bad one because we can actually use our substitution method almost directly. Y equals, and y equals means that negative 3x would have to equal 2x minus 3 directly, and then we want to solve for x, so we're going to subtract 2x from both sides to get negative 5x equals negative 3. And doing the solution for that by dividing by negative 5 gives us x is equal to positive 3/5. The y value that goes with it, well, this is the easiest equation to use because y is equal to negative 3 times 3/5. Which means that our y value is going to be at the point y equals negative 9 over 5. I didn't need a parenthesis there, but I'll leave it anyways. So this is our coordinate point down here. They intersect at the point 3/5 for x and negative 9/5 for y. And we're done. Hooray!